Hello, welcome to this video on differentiation, and you're told to find the equation of the tangent to the given curve at the indicated points. Okay, so this subtopic is equations of tangent to the curve, and I want us to have an idea that the gradient of a given curve is the same as the gradient of the tangent to the curve at that given point. So this idea can be used to determine the equation of the tangent to a curve at a given point. So that's why you're given this point here and the curve. And so what we're going to do here in the solution bit, we're going to differentiate this function, and then we substitute the value of x into that derivative so that we can obtain the gradient, which then together with this point will allow us to get the equation of the tangent to the curve. All right, so let's get started. So we now have our solution here. If you differentiate this function here, you get 3x squared plus 2x, right? Because the derivative of a constant is 0. And then you substitute this one, because this is x, this is y. Okay, if you substitute x here, you're going to get now m is 3 into 1 squared plus 2 times 1. So this gives us a 5, okay? So this is the gradient. Now we have the gradient, and we want to get our equation in the form of y is equals to mx plus c, okay? And so this becomes now the equation of the tangent to the curve. Fine. So we take this point and this point here and the gradient, and we get the equation. Normally we take y minus 3 over x minus 1, that is equals to the gradient, and now we solve for that equation, and we are having 5 into bracket x minus 1 plus 3, and so this gives us 5x minus 5 plus 3, and y becomes 5x minus 2. That is the equation of the tangent to the curve. You see, it matches the equation of a straight line. Okay, so second one, part B says y is equals to x cubed plus 6x squared minus 3x plus 1 at a point x equals to 0. So you notice here y is missing, so we are going to determine the value of y by substituting x equals to 0 in here. So y value should be equal to so we are now working on our solution here. So y should be equal to substituting 0, so you have 0 cubed plus 6 into 0 squared minus 3 into 0 plus 1, and so you notice this becomes 1. So y is 1, so we have a point as 0 comma 1. That checks. Now we proceed with our derivative now. So we have dy over dx of this one becomes 3x squared plus 12x minus 3. Again, derivative of a constant is 0. So we substitute 0 in here, and our m becomes 3 into 0 squared plus 12 into 0 minus 3. So m is nothing but negative 3. So that's the gradient. Okay, so we have the gradient and a point, so getting the equation to match this form here is not going to be difficult. So we have y minus 1 over x minus 0 is equal to negative 3. So y is equals to minus 3x plus 1. All right, so that's the simplest way of writing that equation of the tangent to the curve. Okay, yeah, so in my next video I'll be glad to do the equations of the normal to the curve, which again is a little bit different from this one, because now we shall be dealing with the perpendicular gradients, because at the point of tangency the equation of the normal to the curve is perpendicular to that curve at that particular point. So be careful to follow my videos, and in my next video I'll be glad to doing that part for equations of the normal to the curve. Hope this video has been of great help to you. Subscribe, continue watching to be enlightened more. Thank you.